Anonymous classes. Anonymous classes enable you to make your code more concise. They enable you to declare and instantiate a class at the same time. They are like local classes, except that they do not have a name. So you already know local class, so a lot of materials just directly go to the anonymous class. Use them if you need to use local classes only once. Here is an example. We greet you in 3 different languages, English, French, and Spanish. When we do the English greeting, we implement interface. The Hello World interface have 2 abstract methods. Inside the body of English greeting, we override the 2 abstract methods. In this statement, we instantiate the English greeting by using new keyword followed by the class name, then empty parentheses. When we create an instance of the French greeting, we are not use any class name. Here the hello world followed by the anonymous class body. We also override the abstract methods. This is a French greeting and the Spanish greeting. Notice the difference. We don't have a class named French greeting. English greeting have a class name, but French greeting, Spanish greeting don't have a class. That is why it's called anonymous class. This expression is the anonymous class. The new keyword just create an object and assign it to the variable. Since the hello world, since this anonymous class implements hello world, this assignment is valid. Same thing goes here. And the whole assignment is one statement. And the right side is an expression. So here, as mentioned previously, an anonymous class is an expression. The syntax of an anonymous class expression is like the invocation of a constructor, except that there is a class definition contained in a block of code. So let's run the program. Okay, just get graded in 3 different languages. Good for you. Here, let's consider the instantiation of the French greeting object. The anonymous class expression consists of the following. The new operator followed by the name of an interface to implement or class to extend. This is the interface name. It could be a class name which the anonymous class extends. So it could be an abstract methods. Or it can be a concrete method. So here you can have arguments or no arguments at all. If you have abstract method and or concrete methods, their constructor take arguments you can pass in. Here we have interface. Interface have no constructors, so we use empty pair of parentheses. Next is a class body. In the class body, we can have method declarations, but we cannot have statements. This is not correct. This assignment is definitely an statement, so you can have method declaration as well as statements. Because an anonymous class definition is an expression, it must be part of a statement. This expression creates an object which is assigned to the left side. It is assigned to the variable French greeting. And this assignment ends with a semicolon. The whole thing is a statement. So the assignment is a statement. Assessing local variable of the enclosing scope. Like local classes, anonymous classes can capture variables. An anonymous class has access to the members of its enclosing classes, even though it is private. Anonymous classes cannot access local variables in its enclosing scope that are not declared as final or effectively final. So before Java 8, you have to declare local variable as final in order to access it inside the anonymous class. In Java 8, if nobody modifies the variable, it is effectively final. So the compiler can find it's effectively final and allow you to use it inside the anonymous class. Like a nested class, a declaration of type in an anonymous class shadows any other declarations. This is the same as local variables. So let's first create an instance variable in the outer class. Private int age equal 10. And this instance variable can be this instance variable can be accessed inside the anonymous class, say in French greeting. We just add the edge behind the name and we print again. 10 is appended behind the name. And it is private. The next thing is in the can access local variable in its enclosing scope as long as they are final, effectively final. So the enclosing scope is a method body. We can define a local variable. Let's say mood equal happy, and not int string. And we can access this local variable. So greeting someone, we add the mood. This is allowed. Mood is hello. It's English greeting now. We want to add it behind the French greeting. Okay. In the French greeting, we appended happy. And we can use this because this local variable is effectively final if we are trying to modify it. This is not allowed. The error message says local variable moved defined in an enclosing scope must be final, effectively final. So it's read-only, we cannot change it. And we better to define it as final so that even, oh, not here, heavy. So even the Java 7 can compile. And shadowing, okay, shadowing. We have an instance variable defined in the our class. We can have the same instance variable redefined inside the anonymous class. So this time the age became 100. You see, 100 instead of 10. In order to reference the instance variable of the enclosing class, we have to access it through our class name plus this keyword. If we run the program again, we get 10 back. Of course, you can have the access to the method parameter. If we have int age and say hello, have a parameter with the same variable name as an instance variable age. In this case, if we are trying to print age, we are actually using the instance variable instead of the enclosing class's parameter because the instance variable is closer to the edge. So the closest scope is the anonymous class's class body. So this edge is used instead of a method parameter. In other words, this edge is shadowed by this. We cannot do anything about it. It's just if you want to reference this edge, you can. Oh, of course. Let's show you what will happen. If we have a 333, it won't print out this. We still print out the 100, which is the instance variable of the anonymous class. If you want to access a method parameter, you need to use a different name because this edge is closer. Okay, now we print out edge X. This is a shadowing effect. It always uses a variable in the closest scope. The most closest is the anonymous class body, then the method body, then the our class's class body. So we have 3 levels of shadowing. Next, anonymous classes also have the same restrictions as local classes with respect to their members. You cannot declare static initializers or member interfaces in an anonymous class. An anonymous class can have static members as long as they are final. Okay, here inside the French grading, if we are trying to add a static initializer, we are not allowed. The error message says cannot define static initializer in inner type. Okay, this is not allowed. And what's that other? You cannot have member interfaces. Interfaces can only be declared at the top level. So if you are trying to create an interface, anything, okay, it's not allowed. What it says, the member interface can only be defined inside a top level class or interface or in a static context. It's not allowed. However, you can have a static variable like int v equal 555 as long as it is final. Okay, if this is final, you can use it. And in the French grading, let's add that v. So make sure it take effect. 555 is appended. The variable can be final, it can be non-final, but you cannot just have a static without a final. That's it. And note that you can declare the following in anonymous classes: fields, actual methods, and instance initializers local classes. This is the fields. Those are methods we have to override in the interface. We can have actual methods, like void do something. This is allowed, and we can even no, we cannot call this do something outside because French grading is have the interface type. The interface don't know what do something is. However, we can call do something inside another method. Okay. Instance initializers and local classes. Instance initializer, we have the, say here, string name is Moodle. How about we have an instance initializer, we change the name to something else. And let's print again. It didn't change. The reason is you just you passed in a local variable. So call name. If you Spanish great, you call this first, which passing this is not a good. And someone, okay, this is not a good. You need to name. If you don't assign, and you call this name, okay. And if we don't have the instance initializer, you got a Mondo. If we change it, it changes too. So the instance initializer to take effect. Just mention if we change the order, okay, the one came later wins because instance initializer have the same priority level as a variable declaration, depending on which one came last. The last one wins. And we can have a local variable defined, like a local class defined inside the anonymous class, local class. let's see, equal. We can avoid do something, and you have a class, we have a class body. Okay, do something. And the funny thing is, even though we have a local class defined, and we also create an instance of this local class, we cannot access any of the method defined inside. OCPJP won't test this, but just to let you know, this is an imitation. Looks like local class inside anonymous class is useless. However, we can have it take some side effect, like we can print out something, system out print line, and do something like we say hi. We print, we see this hi. As you already guessed, if you can have a local class defined inside anonymous class, there's no reason you cannot define a anonymous class inside an anonymous class. Greetings. And it asks you to implement the implemented method. Here, since this is a statement, you need to end it with semicolon. And again, this Spanish greetings. Even though you have it, you cannot call any inside methods. The only thing you know it exists is you can create the instance initializer and print out something. Alive, okay. You see. Here is an example of anonymous classes. It uses JavaFX, which is not in the scope of OCPJP, so we will not dig in. We only pay attention to this expression. This expression is created an instance of the anonymous class. Inside the anonymous class's body, it overrides the abstract method defined in the interface. And if we call new, an instance is created which implements the event handler interface. Since the method setOnAction expect a type of the interface, we can pass this instance into as a parameter. Here is another example. Again, as a JavaFX, we will not dig in. The point it's trying to say is anonymous classes are ideal for implementing an interface that contains two or more methods. Later, we will mention Lambda. Lambda can have only one abstract method. Here, if we have two or more methods, we use anonymous classes. Here is this anonymous class expression. Text field is an interface which defines two abstract methods. In the anonymous classes class body, we override those two methods. And this expression just created a new instance of the anonymous class. Since the anonymous class implements interface text field, it can be assigned to the left side. some variable which have the type of the interface. Again, this assignment statement should be ended with a semicolon. The whole thing is one single statement. We just walk through the anonymous class, which is just a local class without a class name.